Okay guys, so our last section in chapter 3 is called Zeros of Polynomial Functions, and we basically have been learning about how to find the zeros of polynomial functions in all of chapter 2 and chapter 3 so far. So really this puts it all together and talks about a new vocab word, zeros of polynomial functions. So what are zeros of a function? And that's what this question is asking us, to find the zeros of this function. Zeros of a function is another word for a vocab word that we've been already working with. So it says a zero of a polynomial function is a value for which the function is equal to 0. So a function is equal to 0 at the x-axis. So that's why zeros of a function are the same things as finding the x-intercepts. And anyone remember, how did we find x-intercepts? We would find the x-intercepts by setting y equal to 0 because they're crossing the x-axis, because the function is equal to 0. Think about another way of saying y. Remember, we would say y is the same thing as f of x. Well, when the f of x is equal to 0, that's what we call the zeros of our function. And we're going to find them. So here, basically the very first thing that you have to do is set the equation equal to 0. So notice I have, let's just get this a little bit better for you. I have the original f of x equals x times x minus 4 times x plus 3. My first step is I set it equal to 0. I don't write f of x equals because I want to find the zeros. And the zeros happen when the equation equals 0, so I have to set it equal to 0. Now what we're going to do is think about, how do I solve for these x's? Anybody remember what it's called that we have to do when I'm already in factored form? This is factored form. How do I solve for this x, and this x? We do something called the zero product property. Remember, where I set each of these factors equal to 0 and solve for x. So I even set this x equal to 0, this whole factor equal to 0, and this whole factor equal to 0. And then I have 3 answers. I have, this is already solved for x. I add 4 to both sides to get x equals 4, and I subtract 3 from both sides to get x equals negative 3. And those are my zeros of the function. Something really cool about the graph of a function, if I graph this, type this right into Desmos, this is what it would look like. Take a second and look at the graph and compare the answers of our zeros to our graph. What do you notice? Hopefully you notice that these zeros of the function are my 3 times it intersects the x-axis. Those are my x-intercepts. Okay, so pretty cool. If I have a graph, I could know right away what the zeros of the function are. I just find the x-intercepts. Let's take a look at another one. Find the zeros of the function. So what is the difference between this one, this function, and the function that we just did? The biggest thing maybe you notice is that this one has parentheses. It's already in factored form, and this one is in standard form. So in order to find the zeros, we need to get it in factored form. Okay, how are we going to get this in factored form? These are our 2 tips right here. We need to take out a common term, and then we'll have to make a factor chart. So looking at 3x cubed plus 6x squared minus 24x, what do 3, 6, and 24 all have in common? They all have a 3 in common. And what else do they all have in common? An x, right? They also all have at least an x. So what we're going to do, remember this, we did this back in chapter 2. We have to divide each of these terms by the common term, okay? So the common term we just said was 3x. So it doesn't disappear, that 3x, it gets written out front of the new equation. 3x, notice it's set equal to 0 now. And now I do this division. So 3x cubed divided by 3x. The 3's cancel. I'll be left with x squared, right? There's 3 and 1. There'll be 2 left over. 6 divided by 3 is going to give me 2. X squared over x will leave me with 1x. 24x divided by 3x will leave me with 8. Those x's cancel. 24 divided by 3. And now, so that was this step, and now we have to make that factor chart. The factor chart in this case would be two numbers that multiply to -8 and that add to 2. Multiply and add. What do you think they're going to be? -2 and +4. So that's how we write our factor setup. Notice now we're at this step as we were last time. This is where it was super easy. If it's already in factored form, I'd go straight to the zero product property. Okay, now it's finally in factored form. I'll do the zero product property. 3x equals 0, x minus 2 equals 0, x plus 4 equals 0. And then I solve each of those for x. 3 times what is going to give me 0? That x has to be 0. Add 2 to both sides, subtract 4. So now when I check this on a graph, what should happen at all of these answers? If you said that's where the graph should cross the x-axis, you are correct. So notice I have an x-intercept here at 0, here at 2, and here at -4. We did it. Awesome job. So besides, there's one more thing we have to talk about. Here are two ways to get it in factored form so I could find the zeros, right? Take out a common term, make the factor chart. What if it looks something like this? There's a third option that we need to know and recognize to do to find the zeros of the function. In this case, what is x squared minus 9? Is that jumping out to anyone? Hopefully, we recognize that it is a difference of squares. Remember that? Back in 3.3, what we just learned, that's when it said if it's a squared minus b squared, we have to do a plus b times a minus b. What jumps out to me is when I'm doing subtraction and they're both perfect squares. That's how I know it's difference of squares. Difference of squares lets me factor it, right? So I know I'm going to set it equal to 0, and I can factor this by taking what's the square root of 9 is 3, and I have a positive 1 and a -1. I'm in factored form, so I do the zero product property, and my two answers are -3 and 3. I can check those on a graph. Notice my x-intercepts. My x-intercepts happen at -3, at -3, and at +3. Awesome job, guys. So try out the examples that I have for you, and that's what this section's all about.